Okay, so in this video, I'm going to talk about the topic from section 15.5, which is um, known as how to do the transpose of a matrix. So, what is the transpose for a matrix? So, suppose you have a matrix A. Okay, so the matrix A is, let's say it's A11, A12, A13, A21, A22, A23. A31, A32, A33. Okay, so suppose you have this matrix A, and this is again what, a 3 by 3 matrix, right? Because the number of rows is 3 and the number of columns is 3. Um, so essentially, the transpose of a matrix is, so it's denoted by this, basically you put A and you put this thing which is called A prime. So this means that what you're doing is you're transposing the matrix. And essentially, the transpose of a matrix means that the first column of this matrix, you're going to take this and you're going to transform it and make it a row. Then the second column of this matrix is going to become its second row, and the third column is going to become its third row. So this is basically, so sort of it's basically something where you rearrange the terms, but you do it in a specific way, okay? So the way you're doing it is, again, you're going to be taking the first column and then turning it into a row. So what's our column, right? So from our original matrix, our column is A11, A21, A31. So you're going to write this like this now: A11, A21, A31. Then you're going to take your second column, which was A12, A22, A32, and then you're going to make this a second row: A12, A22, A32. And finally, you're going to take your third column and you're going to make it the third row: A13, A23, A33. Okay, so this, once you rearrange these terms in this form, you get this matrix which is called the transpose of A, or it's known as, or you denote it with an A prime. Okay, so let me show you a couple of examples. So over here in the book, there's this example 15.5.1. So the thing with when you're transposing a matrix, so number one, it doesn't have to be a square matrix. Okay, you can make you can do a transpose of any matrix. And obviously, when you're going to do a transpose, what is going to happen is, so the number of rows and columns in the original matrix is going to flip in the transposed matrix. So let me just show you. Okay, so in this in the textbook, they have this example that the matrix A is given as -1, 0, 2, 3, 5, -1. Okay, so you have a matrix A. Now what is this matrix? Let's look at the dimensions: 3 rows and 2 columns, right? So you have this matrix A. Now if you're to find the transpose of this matrix, so if someone says, okay, do the transpose, so what do? So the column of this matrix is going to become its row. So -1, 2, 5 is going to become the first row, and the second column is going to become the second row: 0, 3, -1. Okay, so this is the transpose of the matrix. So notice what is the dimensions of this matrix A prime. Now this has 2 rows and 3 columns, right? So these dimensions have just switched. So this is how you take a matrix and you do a transpose of it. Now there's another example in the textbook as well. So let me do just one more. So in the second case, they have a matrix B, and the matrix B is in this form: 1, -1, 0, 4, 2, 1, 1, 1. Okay, so you have a matrix B. What is the dimension of this? 2 rows and 4 columns, right? So you have a 2 into 4 matrix. Okay, so what will you get if you do the B prime or you do a transpose of this? Remember, this column is going to become the first row, this column becomes the second row, this column becomes the third row, and this column becomes the fourth row. So this is your matrix B prime, okay, the transpose of B. And now what has happened to the dimension? Notice that now it has 1, 2, 3, 4. This is 4 rows and 2 columns, right? So these dimensions have just flipped. Just okay, so just continuing on this discussion, on page 600, they write down some rules of matrix transposition, rules for transposition. So I'm just going to, these are important rules you need to review. Okay, so what are some of these rules of doing transposition of matrix? So the first rule says, if you have a matrix A, and let's say you take the transpose of it, and then you take the transpose of this again, you're going to be left with the original matrix. Okay, so again, you had a matrix A, you took the transpose, and then you took another transpose of it, you're going to go back to your original matrix A. This is rule 1. Rule 2 says, if you have two matrices A plus B, you want to find the sum of it and then take the transpose. This is the same as A prime, B prime. So if you were to add two matrices and then take the transpose, the resulting matrix will be the same as if you took the transpose of A and then added it to the transpose of B. Rule 3 says, if you have a scalar which is being multiplied to a matrix and then you're asked to take the transpose of this, you can just take the scalar out. Remember, the scalar is a constant number, right? So if it's just one number, so if you take the transpose of the same number, it just stays the same. So this is just going to be scalar into A prime. So this transpose really doesn't affect the scalar, okay? And number 4, and this is a very important rule. So if you're multiplying two matrices and then you're asked to take the transpose of it, the result is B prime, A prime. Okay, notice this carefully again. Suppose you have two matrices A and B. You were multiplying this and then you were taking the transpose of the resulting matrix. This is the same as if you had multiplied the transpose of B into the transpose of A. But here just remember one thing. Remember, when you're doing multiplication, the order is important, right? So over here, notice that the order has switched. So over here you were doing A into B and then taking the transpose. This is the same as taking the transpose of B and then multiplying it to the transpose of A. So these are important rules to review, okay? Yeah, so in the next video I'm going to do some more problems on I'll solve a few more problems from this section.